Hi everyone, today I'm gonna talk about palm oil. So, palm oil is the largest commodity that can produce a large amount of oil among other plants. So, it's basically a tree that really similar looking uh, with coconut because it's leaf but the distinct one is the fruit of palm oil is really yield to the large amount of oils. It's among the, the best oil produce, the best oil uh, storage of natural storage of oil that found in among other fruits, for example, like um, date fruit. So the best palm oil itself is the best things about palm oil itself. It's only um, live in the tropical region, right? For example, like Indonesia, Africa, Latin America. So the tropical region in the equator. So this kind of unique region that it's require make this kind of commodity is um, really catch a eye because it's necessity, it's a high demand that also resulting in deforestations in some countries of equator, which is have a large of amount of forests to to replace with palm oil, um, to palm oil plantations. So this kind of controversy is really rising right now due to massively from the West, right, from the Europe, that require sustainable practice, but they not have ability to think their own. So their project or the process their anger to other countries that nothing to do about that nothing that struggle to growth on their economy, right? So Indonesia is also one of the producer, the very important producer of palm oil. So currently Indonesia is responsible for 80, almost two-thirds of the crude palm oil to other products, to another countries, to another commodity that use palm oil as the base materials, for example, like cosmetics, food, and many more. So Indonesia is currently also faces a significant challenge due to its boycott, or the negative campaigns of some these company, right, these downstream company that require their product to be more sustainable. So there are a shift towards, I don't know, more sustainable practice of palm oil plantations, which is very low in Indonesia, because another factors such as like technology adoption from some farmer and many more that really low in Indonesia. So it's the basically the adoption itself is already high, but I think the public, the how we project our own palm oil, how we protect them, and how we project them in 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 national, in international view is, I think, really lack in Indonesian people. So that's why I think we need to work more about that, and I think that's why the public speaking and storytelling of leader or diplomacy is really important to bring these issues up internationally and legally and justifiably. So another thing to talk about is really recently that palm oil is also, Indonesia's got a got sued in WTO by Europe, but the recent news is the Europe is the WTO is um, reject the suit because and prove that that European law towards palm oil, Indonesian palm oil commodity is unjustified. So this is really not shocking, by the way, because this kind of negative campaign is that not really not what we really expect from advanced countries like Europe, right? Because you know they have should doing more of technological advance in green energy instead of in green technology instead of just blaming to another countries, right? So I think this is project how decreasing and incapability of innovation that happening in Europe. And another thing that I want to say that palm oil is really effective in their oil production relative to another community or plant, for example like soybeans or sunflower, which is grow in Europe in Western but not produce efficiently more oil relative to their land use. So palm oil is really stand out in oil productions. And there are several problems of palm oil industries in Indonesia, among other like political issues. I think one of them are how we can maintain the oil production uh, high enough, particularly in increasing demand for its commodity, for its derived commodity. One example is how we can make not only we can make more durable or more heat tolerance, more stress tolerance plants or seed, but also we need work on the processing of palm oil itself, which is one of the area that I really interesting. So currently that after plantation of palm oil, so we got the fresh fruit bunch, we call it FFB. This FFB is what really goes to the meal processing. So meal processing unit is where the FFB will get crushed, boiled with very high pressure and heat to get the oil out of the fiber, right, of the fruit and another kind of unneeded compound or to oil. I mean an unneeded compound or that can destruct purity of the oil. The thing or the process of doing extracting oil is really pretty much the same, almost 100 years since the starting of palm oil industries, because it's so traditional way that requires a lot of pressure, energy, and of course water. That's why we have a lot of what we call pommy or liquid or waste that is contain a lot of component, not only oil that lost that not get extracted, but also another component that really not useful to the environment and really toxic. So that's why they need to get process in another problems. It's adding a lot of complicated problems also in the downstream waste, right? But one thing that I really interesting is how we can more efficiently extract this oil out of from its FFB, right? Because at the end of the day, the oil loss is 1%. Currently, the oil extracting capacity, or we call it oil extraction rate, in palm oil industry is average 20%, 22%. Sorry, it means that there are 20 um, 22 oil that get from 100 100 fruits. So that's why. So that, but the truly potential of oil from one's FFB is actually up to 60%, right? 40 and 60%. But because there are some processing problems and losing in another kind of form, we only can optimally get up to 28%, right? But average meal is 22% OER, or oil extraction rate. This is really small gap, but the way that we can increasing 1% is really, the effect is really huge, right? Because imagine that 1% adding of OER in palm oil extraction methodologies or processes is impact to, like, I forgot the number, but it's around like 3 trillions value, 3 trillions rupiah added, right, to the same amount of oil, meaning that we cannot require a lot of another plantation or another the same amount of plantation. And this is very very efficient to reduce uh, the unnecessary loss that at the end of the day will beneficial to reduce the environmental impact of palm oil plantations. Why? Because this is another reason why the negative campaign to the palm oil is because the deforestation is really high, right? Because palm oil is require a lot of money, a lot of water, a lot of nutrition that make uh, a lot of ecosystem lost in its region of plantations. So that's another, my main focus is how with the technology we can increase this kind of oil extraction rate, right? 1% or 2% or even like 5% is this amazing breakthrough, because there are very little technologies that already trying to solve these kind of problems. So since I really enjoy doing synthetic biology, so I try to figure out what is the technology, the workable technologies that can leverage the extraction uh, rate of FFB, right? So FFB is like another fruit. It has a seed. It has a kernel, and it has like mesocarp, or like the meat itself that produce oil. We want that kind of mesocarp, right? The kernel, between the kernel and the surface of the fruit. These kind of mesocarp, what it is contain a compound, a fiber which is contained of like cellulose, cellulose, hemicellulose, and lignin, which is a very complex cell wall in plant, right? Because as they are very strong, like in plant cell, what make the distinct between uh, you know cells in plant is they develop this kind of very thick and robust, very complex cell wall, what we call cellulose, right? So this cellulose is um, contain the oil, right? Inside the cells there are like fat storage, glycerol storage, like lipid storage. We want to break the cell wall first. So how we doing this? The most easiest way is just to boil them, right? Just to break with heat, just with molecules that punch each other, so it breaks. So cellulose or chemicals will break, but it requires a lot of energy. So how we develop new methods? Using what we call enzymes, right? Enzyme is a protein or another chemicals that link in the change that fold to specific 3D structure. The amazing is this kind of sequence or this kind of chain has a specific unique feature of each change. A single unit change has their own physically and chemical characteristic. So this kind of chain is fold in very three-dimension way to perform specific action to change another chemicals. For example, like if you want to break chemicals, there are enzyme called. If you want to break chemicals, for example, like cellulose, there are enzymes that work on that to break the glucose bonds between uh, uh, a glucose polymer or glucose change, right? This kind of enzyme is called cellulase, or another kind of um, glucose breaking enzyme. This kind of enzyme is really robust, meaning that they perform chemical not randomly, right? Not because the enzyme and the change they want to bring is meet coincidentally, but because it meets, in kind of very attractive way or attractive force that once it attach each other, it will develop, it will work on functions, right? So there are the possibility of when it attach it will work. So let put that way. So that's why enzyme is what we call the catalytic machine, because it's make the reaction faster, right? Instead of just punch a bunch of molecules like get pushed and 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 break, because it's just like what it calls, it's just like crush each other, not like that, because enzyme is really specific. It just attach and it perform functions towards the target molecules. So my ideas is how. So currently enzyme utilizations in oil extraction processes, in palm oil extraction process, is difficult, because first, enzyme is expensive, meaning they are, it's really hard to produce enzyme, because we need to over express them in one organism that produce them, right? And the second one is they are really susceptible to environment, for example like heat, because they are just a change, right? A chain that can be break up by heat, right? Because when another molecule hit them, they can break them the structure, so it will not longer works. That's another kind of hurdles why enzyme technology is really difficult to go to commercials. And another point is, I think, because not only it can be destroyed by heat, but also by another chemicals like ion, or another like chemicals that can block the function of enzymes, and or change its structure, or block the the active site, or the site that really make the function, the site where the function of the reaction happen, right? This kind of problems is really make the enzyme is really difficult to commercials. And particularly in the palm oil mill, The problem is more about also in the purity, right? How enzyme is not you know make the product, the oil, uh, dirty. I mean, you need pure oil. You cannot have another substances or amino acid or another nitrogen from enzyme uh, in the oil, right? So how we can separate this enzyme and incorporate them in the process in the meal itself is very difficult. Another thing is, I think, how we can also reutilize this enzyme after it's go in the first process, how we can utilize them in the second process or in another third process so it can reusable, because enzyme is expensive, right? So that's another kind of problems that really make this kind of enzyme solutions really difficult. But I think is the enzyme technology is still developed. The ability that we want, that we more understand how it work, how the enzyme behave. Even we cannot understand enough enzyme in the nature itself. Maybe there are some enzyme that are really robust or more heat tolerance, or even like more efficient in degrading cell walls, plant cell walls. So we just don't know that, right? These kind of tools that currently developed by biotechnology and synthetic biology communities, like integration of AI, computations, this is what really make the promise in enzyme solutions in the future. And yeah, that is, I think, what I want to share today about the palm oil and the enzyme project that I am working on. Thank you for listening.